Hello, good afternoon, everyone. I think it's about time to start these sessions. This session is about I think it's about soil stabilization, but it's mentioned here is about admixture in geotechniques. But all paper is about the soil stabilization, I think. My name is Panit Butiplik from King Mongkut University of Technology, North Bangkok, and my co-chairman is Dr. Raksari Sukharak. We are from the same department from King Mongkut, North Bangkok. And today we have, not today, sorry, this session.
For this session,
Today I think we have more than this. In this session, we have four papers to present. And the first one, I think he is ready now. The first one is about the strength development in cement and fly ash as Big Bangkok clay with considering shear wave velocity. And the presenter will be Mr. Sakon Pochalat.
first presenter is Mr. Skon Pochalat. Now he come from the King Mongkut University of Northern Bangkok. Now he is a PhD candidate and with the experience of civil engineering for 23 years.
Yeah, Mr. Sakon, I have to remind you that you have 12 minutes, 10 minutes for presentation and another 2 minutes for Q&A, okay? And 8 minutes, you will hear a ring bell to warn you that it's gonna be 10 minutes, okay? You have to hear the ring bell. Okay, you can start now, we're ready. Yeah, please.
Thank you. I'm working for Son State University. I am civil engineer. I also PhD student in Doctor of Engineering program at King Mongkut University of Technology, North Bangkok. My colleagues are Mr. เฉลิมพล วังสำเภา and my advisor, Dr. กีรติการ ปริยกุล Today, I would like to present my work. My topic is strength development in cement and fly ash admixture Bangkok clay with considering shear wave velocity. Outline of the topic: introduction, objectives, methods, results and discussions, and conclusion. Introduction. Bangkok has a big problem with settlement because it is located on a very soft clay layer, especially when it has very high water content and very low strength. This picture failure surface because underground high water content. Objectives. 3 objectives to find the optimum proportion of fly ash, to investigate the aging effect of this soil cement, and to find the relationship between shear modulus and unconfined competitive strength. Method. Bangkok in middle of Thailand, soil cement, soil clay sample from King Mongkut University near Chao Phraya River. Depth for 10 to 12 meters. Portland cement, Taiwan, and fly ash are waste from Mae Mak power plant at Lampang province located in the northern part of Thailand at ASTM C618 fly ash F class. This picture table 1 chemical composition of Bangkok clay, Portland cement and fly ash. Silica oxide, aluminum oxide, iron oxide, calcium oxide, magnesium oxide, and sulfur. Bangkok have silica oxide 62.5, OPC 20.90%, and fly ash 37.34. Table 2 property of Bangkok soft clay. Liquid limit 88%, plastic limit 34%, unconfined composite strength 14.5 kilopascal, specific gravity 2.68, moisture content 81%, and unit weight 1.47 ton per cubic meter. This picture, table 3, mixing proportion of Bangkok clay sample. DIK used 6 samples at 101.36. Curling time at 7 days, 14, 28, and 90 days. OPC sample 1 non-replacement with fly ash at 25.34 and replacement fly ash 10%, 15%, 20%, 25%, and 30%. Water content 88%. Bender element test NDT. Computer calculate signal to digital to analog converter to function generator, signal sine pulse to Bender element, path soil sample to oscilloscope, to function to computer, shear wave L by T, L form towel T, pass soil sample, can calculate shear modulus equation at ASTM D8295. Unconfined composite strength LVDT used 50 mm and load cell 50 kilonewton. Used ASTM D1633. Result and discussion. Shear wave velocity versus curling time at 7 days, 14, 28, and 90 days. At 90 days, 20% fly ash, high shear wave velocity. Initial shear modulus versus curling time. At 90 days, fly ash 20% fly ash, high modulus. Once by considering the shear wave velocity and the initial shear modulus, the fly ash replacement of 15% and 20% is fly ash optimum. 2. The shear wave velocity and the initial shear modulus indicate that the optimum fly ash replacement is equal to 20% at 90 days. And the relationship between shear modulus and unconfined compressive stress is fly ash shear modulus equal 27.57 unconfined composite strength. Thank you very much for your attention.
Okay, thank you very much for your presentation. Any question from the floor, from the audience? You have any questions? No? Mr. Surat, you don't have any question? Because you're going to be the second. If you don't, maybe he will ask you later. Huh? So you have Ajahn Napadon, sir? You don't have? Ajahn Laksari, you have any question? Huh? We want to know about the sample preparation. Why you have to keep the OPC constant of 25 grams something?
OPC 25
gram, right? You use the soy of 101 grams.
I replacement bias replacement OPC by bias check strength replacement of strength of soil cement at bias 15 and 20% near pure OPC.
No, I wonder why you have to use dry clay of 101.36 gram and you use the OPC 25.34 gram. Why you have to keep this figure?
What is the idea? For
because of the unconfined composite strength is good or is comply to any standard something?
Idea I use test NDT test use unconfined composite strength detective use long time shear wave test.
You can speak in Thai if you, I think it's better for you if you can explain in Thai. Yeah, in Thai is okay because I think I'm quite confused with your answer. Speak Thai, please. พูดไทยก็ได้
ครับก็ที่ไอเดียที่ใช้ตัวนี้ใช่ไหมครับครับก็เกิดจากว่าการทดสอบที่นำตัวอย่างมาบางทีตัวอย่างที่เก็บไว้ครับเราทดสอบปุ๊บมันก็จะถูกทำลายแล้วก็บางทีการเทสอาจจะเกิดมีปัญหาหน้างานเราเก็บตัวอย่างไว้อาจจะไม่เพียงพอซึ่งการใช้เชลเวฟเข้ามาทดสอบเพื่อจะได้เก็บตัวอย่างนั้นใช้ได้อีกเวลาเกิดปัญหาในอนาคตอย่างเงี้ยครับลองเทอมก็จะเก็บ
Okay, I think he tried to answer the question. He said because of the sample it will be destroyed and they has to use shear wave method. Okay, okay, thank you, Mr. Sakon Pochalat.
Thank you.
Okay, I think it's good experience for you to present in these international conferences. And next.
Okay, the next presenter is Mr. Surat Bhattarai. Mr. Surat, he will come with the topic of pinhole test of dispersive soil treated with cement content by deep mixing method. A case study of Morasup Dam.
I think Morasup Dam is not in Thailand, no?
It's in Thailand.
In Thailand, Morasup. Yeah. I never heard this one.
Southern part of Thailand, sir.
Morasup. What is that? In which province?
I'll explain in my slides.
I think Morasum. Okay, you have 12 minutes, huh?
Yeah. Sorry, sir.
You have 10 minutes for present and 2 for Q&A. Yes, please.
Thank you very much for the organizer committee for this platform. So my research topic is going to be in the comparison of the pinhole test of dispersive soil treated with cement content. And this is one of the case study of the Morasup Dam, which is in Thailand. So first, for the location of the dam The dam is situated in the southern part of the Thailand. It's in the Prachuap Khiri Khan province, almost 400 kilometers from Bangkok. The dam is a homogeneous dam, and it is 12-meter high and 450-meter long. So the dam was constructed in 1995, and since 2012, the dam has undergone 4 failures. And the recent failure occurred in 2019. And after the failure, the dam has been recently rehabilitated with the soil cement column and recompaction in the affected area. So when the rehabilitation work was carried out, the soil cement column and the excavation work was carried out simultaneously. So after the excavation work, the excavated slope was found to be highly dispersive as per the previous research that Ajahn Sutisak had carried out. And after the dispersive soil was found out, the partial work of the soil cement column was already completed. So this is the plan view of the soil cement column that was carried out in the crest zone of the dam. So the overlaps section of the soil cement column. And after this, when the dispersive soil was found, there was a case that if the cement would improve the quality of the soil and its erosivity characteristics. So during the methodology, the field investigation of the soil cement content was calculated, and the similar pattern of soil cement column was illustrated in the lab. So in this case, 16.9% of the cement was mixed with the soil sample, and the soil samples were mixed together and compacted in a pinhole apparatus. So after the test was carried out, there were completely 2 different results. One can be seen, the pinhole test of the dispersive soil, which gives cloudy discharge and erosion of the particles. And in the next one, the dispersive soil mixed with the cement content, which shows there is no particle erosion. And when the pinhole test was carried out, the flow rate and the test time were plotted in the graph. So this also shows that when the head was constant for the dispersive soil, the flow rate increased steadily, and when the soil which has the cement content didn't have the increase in the flow rate for the constant head. So when the head in the pinhole test was increased, the flow rate was increased. So this can be seen in the green portion of the graph. So in the conclusion, we can say that the dispersive soil with the cement can control the dispersivity and the erosivity characteristics of the soil. And this also ensures that when there is internal erosion or the concentrated crack in the column, then it will not enlarge rapidly. And there is also further research that has been carried out after this experiment, because the dam is 10 meter high, so the cement column will be 10 meter high, and therefore next experiment will be carried out with the pinhole test that will have 10 meter highs of pressure head. Thank you. So
Okay, thank you.
I wanted to keep it short and sweet, so that's all.
Okay, now I know this moral swap Morasop Dam is the dam in Bang Sapan, Prajop Kirikan.
Oh, yes,
Yeah,
sir.
the name in Thai is Morasop, but I don't know. I thought that is the name in your country because I never heard this one before. Okay, any question you may have? He prepared many answers. Yes, please. Yes.
PowerPoint presentation and your explanation. And I have one question about the slide you show about the deep mixing method, the diameter. When you show the view, the figure you show during your presentation at the beginning. So I would like to ask, what is the improvement ratio of the surface?
Sorry?
Improvement ratio.
Yeah.
I didn't get your question perfectly.
Like when we have the dimension rectangularly of the area you want to improve.
Oh, yes.
So you place each deep mixing method, each column,
Yes.
and based on the total surface, you need to have like the improvement ratio to have a kind of optimum utilization of the whole surface. So I would like to know.
Yeah. Okay.
Okay.
Actually, we have the same method in Saga, and our improvement ratio is based on, we have the Ariake clay, which is very soft with high compressibility, low permeability. So we divide the surface of each column by the whole surface. Based on that, we have the improvement ratio. I don't know which method you have.
You're talking about in the field. Yeah.
Yeah, yes.
Okay. Actually, the research is based on the laboratory test of the.
I see.
So I haven't calculated that section, the improvement ratio of the soil cement column. So I need to check for that one.
Thank you very much.
Okay. Okay, Professor Sutisak, please. Yeah, his advisor want to answer this question. Yes.
Yeah, I'd like to answer your question. I think a different aspect because what we did in the field, this is the soil cement column for the barrier. But what you ask is the soil cement column to reduce the sediment, right? That different aspect. This is like a barrier.
I see.
Right, like a dam. Yeah. Right, not sediment control. Yeah.
This is in the core of the dam, something.
Yeah, on the center of the dam.
Okay, Dr. Raksiri, you want to ask question?
Oh, actually, your work is based on laboratory.
Yes, sir.
Oh, it a bit confused to me that based on your topic, it seems like you test pinhole test on the field, like a case study on the Morasop Dam. Any comparison between the property between the field and lab test?
And yes, sir. In the field, we have found that the dispersive soil was present there. So when the rehabilitation work was carried out, we found the dispersive soil in the dam section. So when we found the dispersive soil, the half of the work of the soil cement column was already completed. So we wanted to make sure that the cementation process would change the dispersive property into positive way, sir. So that's why the laboratory test was carried out, sir.
Okay. Okay. Any questions? Okay, if there is no question, thank you very much, Mr. Surat Bhattarai. Thank you so much. And the next presenter is Mr. Sayamili Sama.
Miss Salamili Sama, she will come with the topic of characterization of coal mine waste in northeast Kerala of India.
Okay, please.
Thank you. And good afternoon, everyone. Myself, Shamli Sharma. I am research scholar from Indian Institute of Technology, Guwahati. And today my topic of presentation is characterization of coal mine waste of Northeast collieries of India. So this is the outline. The demand for natural resource will continue to rise as a result of successful society's ongoing technical advancement and urbanization in tandem with the population growth worldwide. And it is estimated that by 2050, there will be a global shortage of the natural resources that are mainly required for construction sector. So really we have to think of alternatives, and nowadays we can see there is a lot of work going on waste valorization. Waste valorization has taken center stage in achieving sustainable development goals by addressing environmental, economic, and social challenges. And also, it accelerates the shift to a circular economy. Now, if we take the present scenario of India, the major energy source is thermal power plant. Like 70% of the energy is, or electricity is produced through thermal sector only. And as per the statistics, we can see that the amount of coal that is generated every year, we can see there is a positive increment in the coal production. And as per the economic survey, India's coal demand is said to be 1.3 to 1.5 million tons by 2030, an increase of 63% from the current level. And 90% of this coal that is produced in India, it is through open cast mining. And if we take the coal mining sector, the major issue or the major challenge is the waste management. And over the globe, whatever the waste that is generated during the coal mining process, either it will be stored in tailing impoundment or it will be deposited within the mining site. So if we take the northeast part of the India, whatever the coal generated there, it is in a very pure form. So we don't have any tailing impoundment in northeast India, and only we can see unscientific dumps. And the main economic environmental challenge associated with this coal mining waste is the spontaneous combustion. So spontaneous combustion, as this waste, it contains coal reject. So this is having very high calorific value. So it can result in spontaneous combustion. And another main issue is the acid mine drainage. So acid mine drainage, it is a natural phenomenon. Without coal mining activity also, acid mine drainage can occur, but because of the mining activity, more sulfide minerals will be exposed to the environment. As a result, the acid mine drainage, there will be an acceleration in the acid mine drainage. So here, whenever the sulfide minerals, when it comes in contact with air as well as water, it will undergo oxidation, result in the formation of sulfuric acid. This can dissolve the heavy metals that are present in the waste. So whatever the acid mine drainage that is generated, it is characterized by very high concentration of heavy metal as well as low pH, which can affect the aquatic as well as the biotic life. So through waste valorization, the negative environmental impact of the coal mine waste can be reduced. Also, we can say that the pressure on the natural resources can be reduced. And for any the success of any valorization process, it depends upon, so we have to find out the properties of the waste material before going for the valorization. So the success of valorization mainly depends on the characteristic study of the waste. The characteristic study of the waste is very important for effective waste management planning, environmental impact assessment, regulatory complaints, and research and development. Not only that, for the proper selection of stabilization method also, we have to find out the properties of the waste material. So my objective was to find out the characteristic of the waste of northeastern collieries. Coming to the methodology, So I have collected the waste from the northeast part of the India. Why northeast part? So if we take the topography, because of the topographic nature, the amount of waste generated in the northeast part is more compared to any other part of the country. And also here the coal, it is having very high sulfur content as well as the volatile matter. Presence of volatile matter is very high. Because of that, the chance of acid mine drainage is more in northeast part compared to any other part of the country. So coming to the resultant, and whatever the waste that is whatever waste I have collected, it is collected from 3 different locations of the country. 3 different locations of the coal field, and it is designated as OBS1, OBS2, and OBS3 in the present study. Coming to the result and discussion, if we see the properties, we can see that there is a wide heterogeneity in the properties for all the collected samples. And this can be because of the varying percentage of the coal content. And also, we can see that the predominant fraction is silt and clay in all the types of the waste. And whatever the waste is there, these are having very low plasticity limit. And as per the classification, from the first and third site, it comes under CI soil, and the second one comes under CL soil. And the time swell plot, it is seen that for OBS1, the swelling is more compared to OBS2 and OBS3, but the percentage, if you see the percentage of swelling, it is very less. That means it is not having any expansive minerals present in the waste. And also, like the variation of the void ratio as well as the coefficient of consolidation, we can see it is more for OBS1 compared to OBS2 and OBS3. So coming to the chemical characteristic, so as this is obtained from coal mining site, we have to see whether the waste it is toxic or not. So we have carried out toxic characteristic leachability procedure as per the EPA guidelines. So it is seen that for the collected waste, chromium, lithium, and zinc, it was above the limit. The concentration of the heavy metal was above the prescribed limit given by the World Health Organization. And coming to the mineralogical characterization, if we see the waste from all the 3 locations, we can see that the mineralogy, it is almost similar only. There is not that much variation in the mineralogy, and the predominant fraction, we can see it is quartz only. And we can see there is a difference in like peak intensity, there is difference in peak intensity, but the peaks were similar for all the types of soil. Conclusion, understanding the nature, danger, and waste management alternatives of waste material depends on the waste material's characterization. In the present study, even though the waste soil samples were collected from different locations of the same coal field, it showed a wide heterogeneity in the data. Varying percentage of the coal, it may be because of the varying concentration of the coal mineral distributed within the sample. And the particle size distribution of the sample suggested that silt is a predominant fraction present and the particle does not exhibit plastic characteristic. For the metals, cadmium, chromium, lithium, and zinc, the concentration exceeds the permissible limits as per the World Health Organization. And from the consolidation as well as mineralogical data, it is clear that the waste is not having any expansive minerals. Thank you, and these are my references.
Okay, thank you very much, Ms. Siamili. Any question from the floor? Because the presentation is about the characterization of the coal mine waste, right?
Yes, sir.
But you just characterize it, but you didn't say anything about it. It is the waste, right? And what do? You will do next? You will stabilize, or you will use it as a backfill, or you will...
That's my work, sir. I'm going to go for bioremediation for this waste.
This is just an introduction of your work.
Yeah,
Okay.
yes,
Okay. Okay. No questions? Okay, then thank you very much, Mr. Mili.
Thank you.
Okay, the last presenter for this session is Mr. Yutaro Hara. Mr. Yutaro Hara, he comes from the University of Tokyo. He will come with the topic of geotechnical interpretation of interlayer of structure of fine-grained and coarse-grained soil adopted in Japan or to Mori Kofan.
Okay, I'm going to start my presentation. The theme is geotechnical interpretation of the interlayered structure of fine-grained soil and coarse-grained soil, adapted in Japanese Old Tumuri, Kofun. First, I briefly introduce Kofun. Kofun Tumuri is an ancient burial mound built in the 3rd century and 7th centuries CE, about 1500 years ago. In Japanese archipelago, as many as 160,000 Kofun Tumuri, ranging in size from a few meters to over 400 meters, were built. Inside the tomb, which were built with soil, various spaces, which is called the stone chamber, were created. And some various accessories like the bottom right figures and excavated materials provide a glimpse into ancient Japanese culture. Although there are many theories as to why such huge tombs were built, the most popular explanation is that they were constructed as a symbol of power and a landmark of the family's prosperity. The burial space, called stone chamber, is so sturdy construction that it would remain for decades to allow the family to continue burial. To build a large and solid mound, various civil engineering techniques, for example, filling stones surface on the mound, were applied to protect the mound and the stone chamber. Therefore, Kofun Tumuri represents the civil engineering technology of ancient Japan. The representative unique structure of Kofun Mound is the interlayered structure of fine and coarse-grained soil. It is structure of thin layers with 3 to 10 centimeters, with different grain sizes piled up in alternating layers along the slope of the mound. Here is the example of interlayered structure. But the reason why two different types of soil with different grain sizes were intentionally used is not explained from the archaeological point of view. In this study, the role of this unique structure was interpreted from a geotechnical engineering perspective. Based on the role of mound in protecting the mound and the stone chamber, two hypotheses were formulated in terms of strength and drainage properties, and geotechnical experiments, triaxial compression test, and rain penetration test by sandbox were conducted. First, I am going to explain the triaxial test. In the triaxial compression test, the grain size distribution of two types of soils used in the interlayered structure was reproduced using silica sand, and the shear strength against the compression of the specimen was compared using a confining pressure of 15 kilopascal. First, I show you the effect of interlayered structure on the strength of the mound at the same damping energy. The maximum strength in the interlayered structure, the maximum strength was as much as that of the single layer of fine-grained soil. The fine-grained soil layer was particularly strained in the two interlayered example, and the shear planes appeared mainly in the fine-grained soil layer. For interlayered structure, on the other hand, the same result was obtained as much as fine-grained soil single layer. But the shear plane appeared to straddle the fine and the coarse soil layer. The reason is thought to be that the fine-grained layer, which is more susceptible to compression, was strained preferentially. Next, I show the influence of damping energy. In the both fine soil single layer case and coarse soil single layer case, the maximum stress and compaction degree is increased by the damping energy increases. In the interlayered structure of 2 layers and 4 interlayers, the compaction characteristics and the strength characteristics are close to result of a single layer of fine-grained soil. Next, as an experiment of infiltration characteristics, the rainfall infiltration experiment with a sandbox are conducted. Here is the structure of sandbox infiltration test. The layers of the mound were reproduced in the sandbox, and rainfall were applied from a rainfall device above the box. The changes in the infiltration and surface flow and the amount of drainage at each layer were compared. And the figure shows the relationship between the time from the start of the rainfall and the amount of flow. In the 2-layer case, which is the upper layer is the fine layer, the seepage flow were confirmed in 50 minutes. The upper layer is coarse layer case. On the other hand, the seepage flow was confirmed after 35 minutes. The amount of infiltration was found to be only 5% of amount of surface flow. This is indicate that the most of the precipitation flows on the surface. Here is the percentage of drainage in each layer when the drainage volume of each soil layer was constant. In the 2-layer structure, when the top layer is the fine soil layer, the upper layer drained about 36% of total drainage. In the upper layer is coarse soil layer case, on the other hand, the upper layer drained about as much as 90% of total drainage. In the 4 interlayer structures, the most drainage occurred in the 3rd coarse soil layer, about the 43% of total drainage. It indicates that the fine soil layer has the imperviousness characteristics, and the coarse soil layer have the characteristics of draining infiltrated water. Here is the conclusion. In this study, triaxial compression test and sandbox infiltration test were conducted with 2 hypotheses regarding the role of the interlayered structure of fine and coarse-grained soil. The result is that in the triaxial test, the strength of the interlayered structure is same as a single layer of fine-grained soil, and the increasing in compaction energy enhances the strength of the mound. In the sandbox penetration test, on the other hand, the most part of rainfall from the surface and fine-grained soil layer reduces infiltration and drains saturation of the mound, and the coarse-grained soil layer drains infiltrated flow out of the mound. As I mentioned at the beginning of the presentation, archaeology has not clarified why fine and coarse soil interlayered structure with a thickness of only few centimeters per layer was introduced in the construction of coffin burial mound. In this study, the role of this unique interlayered structure is attempted to explain from the viewpoint of modern geotechnical engineering. As a result, it is found that this fine and coarse-grained soil layer has the relational structure that combines the imperviousness of fine soil with the drainage properties of coarse soil. The issue is that a reason for thin layer thickness of a few centimeters is unknown, and there might be some technical feasibility on construction process, and this is the issues.
Any question? From floor, yes, Ajahn Apiniti, yes, Professor Apiniti, please.
Thank you very much for a very nice presentation. I enjoy it very much. And it's not really a question, this is kind of a suggestion. Have you ever looked at the problems in terms of capillary barrier issue? Like if you look at from an unsaturated soil mechanic point of view, maybe you can find also a nice explanation about how this layer systems of soil cover works as well, like characterizing in terms of a K function, soil water retention curve, or something like that. Yes, please.
Okay. At first, I thought that any capillary barriers effect can occur in the test, but the result is not so, because the capillary barrier flows the top of coarse-grained soil layer and the bottom of the fine soil layer. So and why I think that why capillary barrier doesn't occur is that the coarse soil layer is slightly finer than the gravel or more coarse layer. So that's the my opinion.
Thank you.
Okay, Professor Sutisak, please. Very interesting topic. See, two big professors interested in your presentation.
Just curious about your triaxial test. What kind of shearing mode that you apply, drain or undrain?
In the triaxial test, is the unsaturated condition and drainage condition.
So you shear with the slow rate, right? Or
Slowly.
rate.
Yeah.
Okay, so you get the effective strength parameter at the end.
Sorry.
It's okay. So it's a slow rate, right?
Yeah.
Okay, thank you very much.
Any questions from floor? Okay, now is my question. My question is not like the two professors. I just want to know that nowadays, are there still have a co-fund mount exist? Still have?
Still?
The co-fund mount is still have in Japan? I mean because I wonder when you study about the property of the soil in the mound, and then what you will do next? I mean that you will improve the new smart that you're gonna build in the future, or just want to know the characteristic of in the layer of soil, just that.
My future plan? Oh. sorry.
Okay, no. I just asked that your results in your study is about the soil property of the interlayer in the mouths, in the tomb, right? It's like a tomb. Yeah. And then when you get the results, what you gonna do next? How you apply this result? I mean, you will use it for the nail build of the co-fund or?
Okay, so I think this structure is blocking the infiltration water into the mound. So I could apply these techniques to the structure that can't water infiltration. That unique point is thin layer and about 3 centimeter or 5 centimeter, and it is I think it's the more it has some special characteristic or something.
The highlight of your work should be the infiltration, not the strength. By conclusion for your next study, I think the highlight for this topic should be the infiltration. Okay.
Yeah,